Hi everyone, I'm Sheldon, and this is Friday Farsight. This week we're beginning another two-part series, and our destination is post-scarcity economics, which we'll cover next week. And I think that's one of the most important topics in futurism because it's kind of the destination I think we all hope society will get to, where we live in this kind of utopia like the culture in the Ian M. Banks novels. But on the way to get there, there is a technology called 3D printing or additive manufacturing, which plays a big role in that because if you can think about it, that's taking ideas and printing them directly into matter. So in a way, making things potentially a lot cheaper. So we're going to dive deep into that this week. And the core of the prediction is, when will that be the dominant form of manufacturing? If you're an investor, you might think this is an exciting and obvious investment opportunity. And it probably is. But one thing you'll take away from this prediction is that the market is going to be quite varied, and it will also take a long time to develop. Anyway, there's a lot of detail to unpack along those lines in this prediction. That's why we wanted to set it aside as its own show before we get into the longer arc toward post-scarcity. One more quick note. There was a previous episode some of you may remember called Programmable Matter, and that's just slightly different. That's matter that's been configured in sort of a set of voxels that can be used to print certain classes of objects like furniture, maybe clothing that changes shape. So a little bit different, but you might pick up on some thematic overlap between the two concepts, which essentially are connecting ideas to the physical objects of the world. So that's plenty of preamble for me. I think I'm happy now to hand it over to our hosts, Biff and Betty, remembering that they are AI generated, as is a lot of the content of the show. So take everything with a little bit of a grain of salt.
What you got, Biff?
All right, let's see here. 3D printing, taking over everything by 2090. Betty, I'm going to be honest. My first reaction was, who cares? I'll be compost by then.
Well, hello to you too, Biff. And hello, everyone. Welcome back to Friday Farsight, where every week we dig into a prediction from the strategic Farsight timeline. And this week, it's a big one. By 2090, give or take 20 years, 3D printing, additive manufacturing, becomes the dominant form of manufacturing on Earth. More than half of everything made by value.
More than half of everything. Like my shoes, my car, my toaster? Just press print?
In the manner of speaking, your toaster, your furniture, possibly parts of your house. And here's what hooked me, Biff. This prediction, it argues with itself. The article basically says this might happen by 2090 or 2110 or honestly, never.
Wait. The prediction predicts it might not happen?
That's what makes it fascinating. It's not fate, it's a fork in the road. And which path we take depends on choices society hasn't even made yet.
Okay, see, now I care because that means the argument starts now, today, with you and me on this podcast. We get to put our thumbs on the scale and tip a debate that may not start for decades. What I say right now could determine whether the game controller in little Johnny's hands in 2105 is printed or is built on an assembly line. Why do I care again?
Well, let's set the stage first. Today, additive manufacturing is about 0.5% to 1% of global manufacturing by value. That's from Wohlers Associates. They've been the industry scorekeeper for 3 decades.
1%? That's it? Because the way people talk about 3D printing, you'd think it was already running the world.
Right. There's been hype since the 90s, but it has real niches, and they're telling. Aerospace is the famous one. GE prints the fuel nozzles for its LEAP jet engines.
A fuel nozzle? Forgive me, but that sounds like a glorified spout. Why is that the poster child?
Because that nozzle used to be 20 separate parts welded and brazed together. Now it's printed as one piece, 25% lighter, 5 times more durable, with these intricate internal cooling channels no drill or mold could ever reach. There are like 19 of them in every engine, tens of thousands flying right now. That's the lesson. Printing one there not by being cheaper, but by making a part that's impossible to make any other way.
Huh. So it's not a spout, it's a tiny metal Stradivarius, a sublime instrument like a violin made by the secretive Stradivari family, which would confound archaeologists 200 years from now if they didn't know the secrets of 3D printing. Sorry, I think in metaphors. So what's holding the technology back from world domination? Who's the villain in this story?
Speed, first of all. An injection molding machine can spit out hundreds of plastic parts an hour, cycle times in seconds. A high-end metal printer can take hours, days even, for one complex part.
Days? For one part?
For one part. Terry Wohlers himself said speed remains the primary limitation keeping additive out of production environments. For dominance, you'd need printing to get 100 to 1,000 times faster.
1,000 times. I guess we'll need a Moore's law for printing.
Right, or flashes of innovation. There are glimmers. A company called Carbon has this process, digital light synthesis. Instead of print a layer, stop, recoat, print again, it pulls the part continuously out of a pool of liquid resin. There's an oxygen-permeable window at the bottom of the vat that keeps a thin zone where the resin can't cure, so the part just rises out of the liquid, 25 to 100 times faster.
So the T1000 climbing out of the liquid metal, except it's a shoe sole.
Literally a shoe sole. Adidas prints midsoles this way. MIT has rapid liquid printing that draws furniture-sized objects in minutes inside a tank of gel that holds everything in place. A company called Desktop Metal is chasing injection molding speeds for metal parts.
Okay, but even all that sounds like catching up, not lapping the field.
That's the article's honest take. Yeah, incremental progress toward parity, not the revolutionary leap. Which brings us to the real heart of this, the economics. And Biff, this is the part I want everyone to hold on to.
Hear that, everyone? Wake up and no talking during the podcast, please.
Think about a phone case. To injection mold it, you first have to machine a steel mold, and that mold can cost tens of thousands of dollars. So really, the mold is a bet, a wager that you'll sell enough copies to pay it off. The first case effectively costs a fortune, but the millionth costs cents. The cost curve plummets as volume climbs.
Right, economies of scale, the whole reason factories exist, the whole reason everything in my house was made 9 time zones away.
Now 3D printing refuses to place the bet. No mold, no tooling. The first unit and the millionth cost roughly the same. It's a flat line.
Huh. So printing never gets cheaper with volume, but it also never had to gamble in the first place.
Exactly. Perfect for one-offs and customization, terrible for a million identical things. McKinsey put the crossover at production runs below about 1,000 to 10,000 units. Above that, the mold wins.
So the entire 65-year battle is, can the flat line beat the plummeting curve?
That's the whole war in one sentence. And the article says there are 3 ways the flat line wins. 1, printing costs collapse, materials, energy, machines. 2, society stops wanting identical things. Or 3, traditional manufacturing gets expensive. Labor costs, carbon taxes, resource scarcity. Notice only one of those is about better printers.
The other 2 are about us. Okay, hold on, because I gotta put on my skeptic hat. Some of this feels like it's fighting physics. Squirting molten plastic into a mold is always going to beat drawing the object line by line like some cosmic ballpoint pen. Stamping sheet metal is always going to take less energy than melting powder with a laser. You can't out-innovate thermodynamics.
That's a fair critique, and serious people make it. Christopher Hsu, who headed materials science at MIT, says additive will remain a specialized tool rather than a universal method, the way casting and forging coexist today. Forging never killed casting. They've shared the workshop for 3,000 years.
Right, and there's another thing. Do people even want custom everything? I keep thinking about Andy Warhol's line about Coke, that what's great about America is the president drinks Coke, Liz Taylor drinks Coke, you drink Coke, and no amount of money gets you a better Coke. We voted for that, Betty. We voted for Apple and IKEA. Identical, well-designed, cheap.
That's actually one of the strongest counterarguments in the article: consumer indifference. The customization economy assumes people will pay a premium for bespoke, and maybe most won't. Sameness is cheap, and honestly, sameness is comfortable.
And then there's all the existing factories, trillions of dollars of them. My uncle ran a stamping plant. Those presses run for 50 years. You don't write that off because a printer got cool.
Infrastructure inertia, yeah. And it's not just machines, it's a century of accumulated knowledge, tooling expertise, supply chains, engineering curricula. The transition costs alone could push adoption decades past technical feasibility. But, okay, let me push back because the optimistic case isn't wishful thinking. It rests on material science doing things traditional manufacturing literally cannot do.
Like the Stradivarius nozzle?
Like the nozzle, but further. Lawrence Livermore has printed high-performance alloys everyone swore were unprintable. There's also 4D printing. You print a flat object and it folds itself into shape later when it hits heat or water. Origami with a mind of its own. And Jennifer Lewis's lab at Harvard prints objects with electronics, optics, even living cells embedded inside as they're built.
Inside? So the circuitry isn't assembled, it's just grown in?
It's like one of many tissues in a body, not a circuit board screwed into a case. The case is the circuit. Products impossible to make any other way. And the end game, the holy grail, is molecular-level additive manufacturing, building things atom by atom.
Atom by atom. Betty, that's a replicator. That's literally the Star Trek replicator. Tea, Earl Grey, hot.
It kind of is. The article mentions scanning probe microscopy arrays. We can already nudge individual atoms around. The question is doing it a trillion at a time, and programmable matter. Speculative, but a real research direction, not fairy dust. And add AI on the design side. AI is already designing metamaterials, materials whose powers come from their structure, not their chemistry. Lattices that are mostly air but stiff as solid metal. Materials that get thicker when you stretch them.
Thicker when you stretch them? That's illegal, if not obscene. Matter just doesn't do that.
Natural matter doesn't. These do. It's all in the geometry. And here's the key. Geometries like that often can't be molded or machined at all. They can only be printed. At that point, you're not competing with the injection molder on price. You're selling something the injection molder can't make at any price.
Okay, that's a better argument than everyone will want a custom toaster. So what's the timeline? How do we get from 1% to half the world?
The article lays out phases. From now to 2040, incremental progress. Additive grows to 5 to 10%, mostly aerospace, medical, specialized industry, speeds up 10 to 50x. Then, 2040 to 2060, the breakthroughs start. Molecular printing demonstrated in labs, distributed manufacturing networks serving niche markets, 20 to 30% of...
Whoa. Distributed manufacturing networks, meaning what exactly?
Meaning instead of a factory in Shenzhen shipping products across an ocean, you have neighborhood print hubs, maybe household printers, making things on demand from digital files. The article puts it perfectly. Why pay for a factory in China, container ships, warehouses, and retail stores when you can email the design to a local printer?
A machine in my apartment that produces useful things on demand. So my cousin Roy going grocery shopping, except it works without being nudged.
Roy is more of a robot butler in need of repair. But think about what that sentence means, Biff. The product stops being a thing that travels. The thing that travels is the file.
Matter becomes software.
Matter becomes software. Then 2060 to 2080 is the inflection point, if customization culture takes hold. Because here's the subtle part. Network effects kick in. The millionth printer added to the network makes all the other printers more valuable. Shared design libraries, shared materials supply chains, shared expertise.
Like the internet, but for stuff. Every printer that joins makes the whole thing smarter. Wait, it's Gutenberg. That's what this is.
Before the printing press, every book was bespoke, some monk's whole year. The press made text copyable, and you got the Reformation, science, newspapers, the modern world, basically. This is Gutenberg for objects.
Oh, that's good. And the parallel runs deeper than you'd think. Gutenberg's press didn't change what a book said. It changed who could have one, how ideas moved, who had power. Same here. The printer doesn't change what a wrench is or what a smartwatch is. It changes who can have one, instantly, anywhere.
And hold that thought, because Gutenberg has a dark sequel. If a chair is a file, the chair gets pirated, right? We've seen this movie. It's Napster all over again, except for everything.
That is, the Napster moment for physical objects. The music industry spent a decade in chaos when songs became files. Lawsuits against teenagers, business models vaporized. And you know what finally worked? Not winning the war. Spotify. Convenience beat piracy.
So somebody's going to have to invent Spotify for stuff. Unlimited objects, $9.99 a month, cancel anytime.
Probably. But until they do, imagine that chaos for furniture, tools, car parts, sneakers.
Weapons.
Weapons. It's already an issue with printed firearms today. Untraceable, unregulated, downloadable. Scale that up 60 years. Who certifies the aircraft part that came off a neighborhood printer? Who's liable when a pirated chair design collapses under your grandmother? That fight starts way before 2090.
And think about who loses in this world. If geography stops mattering, what happens to countries whose whole economy is being the world's factory?
That's the geopolitical earthquake buried in this prediction. The entire post-war order is built on manufacturing geography, trade routes, alliances, the world's factory model that lifted hundreds of millions out of poverty. Container shipping moves 90% of global trade. If products become files, that circulatory system atrophies.
Ghost ports. Those giant gantry cranes just standing there, rusting, like herds of extinct animals.
That's the image, yeah. And there's a military version, too. Manufacturing capacity has decided wars. The U.S. outproduced everybody in World War II, the arsenal of democracy. What does national power even mean when production is spread across 100 million garages?
Okay, that's bleak and fascinating. But flip it, who wins?
Designers, for one. In a world where the file is the product, the designer is the rock star.
Finally, took civilization long enough.
And remote communities, too. A village clinic that prints the spare valve or the prosthetic socket instead of waiting weeks for a shipment that may never come. Everyone whose body doesn't fit standard sizes. Every shoe, every chair, every implant fitted exactly to you. Mass production serves the average human. And biff, the average human doesn't exist.
I don't know. I feel pretty average.
And also, space. You can't ship a spare part to Mars. Off-world settlement basically requires this technology.
Right. Every sci-fi colony has the machine shop that makes whatever they need. Okay, so paint me the picture. It's 2090. The prediction came true. What does a Tuesday look like?
You wake up, your kid needs new shoes. Grew again overnight. You scan her feet, she picks a design, tweaks the colors, you hit print. They're done after breakfast. Yesterday's shoes go into the recycler and become tomorrow's something else. No box, no truck, no store, no landfill.
So nothing is really permanent. Objects are just temporary arrangements of material. You don't own a chair, you own the idea of a chair, and you summon it when you need it. That's weirdly Buddhist. Impermanence, but with a subscription fee.
But it changes something deep, I think. For 150 years, mass production made sameness the texture of daily life. Your Warhol Coke thing, there's something genuinely democratic about everyone's stuff being the same stuff.
And if everything is bespoke, that shared material world kind of dissolves, but in a weird way, in how we talk about objects. Lovely chair, where'd you get it? Today, we might say, oh, on this trip to Mexico, my family and I, etc., etc. In the future, it'll be, lovely chair, can you send me the spec? And I'll say, sorry, it's me-shaped, scan your own hindquarters.
Right. At least today you can talk about where to buy something.
They're on sale at Target. You might like the blue one.
We probably don't recognize just how much talking about stuff, about the physical world around us, is really woven into human relationships, into the fabric of a community.
That's the whole purpose of a tribe of humans, right? The apples are ripening in the valley. The bison are on the move.
There's a sale at Target is already a diminution of that, but it's something.
So where does this lead? We'd trade Spotify playlists of all of reality?
Maybe. Something like that. The albums, the individual artists, they start to fade into the background. Our relationship with the individual thing, it changes. And this could be the biggest shift culturally. When anything can be reprinted, what's precious? There's an essay I've been carrying around since college, Walter Benjamin, the 1930s, The Work of Art in the Age of Mechanical Reproduction. He said even a perfect copy of an artwork is missing one thing: its aura, its unique presence, its history, the fact that this object was there. He was talking about photographs of paintings. We're talking about every object in your life.
So when my grandfather's hammer can be scanned and reprinted molecule for molecule, it's not his hammer. The copy has the shape, but not the having been held.
That's the aura, exactly. And maybe that means sentiment dies. Or maybe the opposite. Maybe the only luxury left is the thing with a history, the handmade, the inherited, the irreplaceable.
Craftsmanship becomes the caviar of stuff, the one object in your house some human actually touched.
Maybe so. But, okay, I have to be honest about where the article lands, because it's not the full sci-fi ending. The author's actual bet is that 3D printing never becomes truly dominant in the simple sense. The likely future is a hybrid, 40 to 60% of manufacturing involving additive methods somewhere in the process, mass-produced where mass production wins, printed where printing wins. A car with a traditionally made frame and engine, and an interior fitted to your body.
So not a revolution, more like a merger.
A merger where the line between 3D printing and just manufacturing stops meaning anything. And the article has this historical anchor I love: electricity replacing steam. Here's the thing, most people don't know. Electric motors were proven by the 1880s, but for decades, factories barely benefited because they just yanked out the steam engine and installed one giant motor in the same spot, still driving everything through the same maze of overhead shafts and leather belts.
They electrified the steam factory instead of building an electric one.
Precisely. The payoff only came when engineers redesigned the whole building. A small motor on each machine, the factory laid out a round workflow instead of around the drive shaft. That took 50 years. Basically, a generation of engineers had to retire.
So even if every printing breakthrough lands on schedule, the world needs 2 generations to digest it. The factory of 2050 is probably a printer bolted into an assembly line doing it wrong, like the giant motor.
That's why 2090. It's not pessimism about the technology, it's realism about civilizations. And remember the fork in the road. This future doesn't just arrive. The article is explicit. It requires society to prioritize customization, sustainability, distributed resilience over the raw cheapness of mass production. That's a choice. Possibly a choice to pay more per object, for objects that fit us and are made next door out of yesterday's objects.
So the future of manufacturing is a referendum on what we value, and we vote every time we buy something.
The market will decide, and we're the market. The article's last word is the one I'd put on a poster. The revolution will be more subtle than the enthusiasts imagine, and more profound than the skeptics expect.
I got to admit, I came in ready to dunk on this one. Instead, I'm sitting here mourning a container ship and clutching my grandfather's hammer.
That's the show, folks. Thanks so much for listening to Friday Farsight. If you want the full prediction, the timelines, the technologies, the whole debate, head over to the Strategic Farsight website and read the article. And while you're there, add your own take to the timeline.
See you next Friday, my freaky far-out Friday Farsighters.